So thanks a lot. Now we'll have Côme de Chanay. He's a student at ECAM Rennes in France, and he's a former trainee from Folkecenter. So he has been here not so long time ago. Now you should be able to unmute yourself. And he will tell us a little about the project he has been working here. And then for those of you who are here in presence, we actually have the turbine that he developed up there, so you can have a look. But yeah, welcome and thanks for being with us.
All right, thank you. Does everyone hear me? Is it fine for you?
Yes, perfect.
Yeah, it's perfect. All right, I'm gonna share something for you guys. All right, where is it? Yes, there we go. What do you see? What do you see? All right, do you see the PowerPoint?
Yep,
Are you
perfect.
good? All right, so nice. So hello everyone, hope you're doing okay. It's a pleasure to be here, speak about my little project I've been doing at Folkecenter. I think it was 3 or 4 months ago. I stayed at Folkecenter for 3 months, and I've been mainly working on the potential of 3D printing and to combine it with small one-to-bind production. Just a little word about myself. I'm an engineering student. I've been formed to generalistic engineer, but I've been abroad in Australia to complete my formation and to improve my knowledge in political environmental issues, especially in Australia, which is something very interesting, and I recommend you to have a look at that. So I've been working mainly on the power of 3D printing for the last 5 years of my free time I had in my life. I'm doing this quite a lot, and I am now working with a company that is printing metals like titans and steel with 3D printers that are actually huge machines. So I've been doing this quite a lot, and I took the chance at Folkecenter to improve my knowledge in small wind turbines and combine those my skills in 3D printing with this kind of technology. At Folkecenter, I mainly understood how small wind turbines and wind turbine worked. I studied the potential of 3D printing and production of wind turbines and complex designs. I had the luck to test one prototype I have been printing and explore the possibilities of the project. I think if you ask Daniela will be very happy to share with you the document, the form I have made about my research and the result of the experiment I have completed here at Folkecenter. So on the left of the screen, you can see top left, you can see the design I've been working with. And the conclusion here is after experiment is that the 3D printed blades have a very high efficiency ratio at a very low speed winds. And this is due to the complex design that you can print with 3D printing, because 3D printing is a way to build that is very flexible in space, in 3D space. It's also due to the light weight of these turbines. It's less than 200 grams for the 3 blades, if I remember well. It's been quite a long time. From the experiment, we have concluded that this kind of prototype could produce enough energy to charge small batteries that can charge phones, as an example, and that can light up LEDs for quite a lot of time. These also have the capacity of having a very low production cost I think the production cost of these wind turbines that you see the prototype with the generator is less than 15 euros. I'm not counting the printer, but this is something we can talk about later. And that was quite an easy process of fabrication. The maintenance is also very easy to do, and the installation is also quite easy to do. I think it took me maybe half an hour to assemble everything, and I was alone. So what is the real world impact about this idea and this project? This project is in response to a higher and higher need of low carbon energies in developing countries, and also the higher need of mixed green energies to mix the energies together to be to be less dependent. The idea here is to use and to bring the flexibility of 3D printing in developing countries for renewables energies and improve the energy access in rural areas. This is going to bring a new form of energy, bringing local durable solution for the population that is in need of energy solution right now. This will be also the occasion to train and educate the local population to this kind of technology, which is something that is very easy to access if you have a small amount of money, a computer, and some plastic. So this is very basic stuff. This is going to create jobs as well in those countries, creating an economic activities on those developing countries, and those are very low economic activities area that we are targeting right now. So this is going to help a lot the local population. We will allow the local population to be self-sufficient in wind energy. They will be able to produce and repair their own small wind turbines by themselves if the education is working well. So what are going to be the next steps for this kind of idea and project? The next step for tomorrow is to develop a 3D printed sustainable design of small wind turbine. Of course, the prototype that I've been doing is quite basic. It is too basic. There is a lot of tests to do. There is a lot of tests for very high speed wind, very low speed wind. We need to test the materials. We need to test the resistivity of the prototype with time, weather, heat, all that kind of stuff needs to be combined to fit one suitable design. We also need a bigger design that I have been doing if we want to fit household scale production to local use. The one I've been doing at Folkecenter is maybe too small. So we need something bigger. So we need to think about a new design for the blades that can take all the forces of the wind. Next, if everything goes right, we are going to launch a training program and to try to form the local population to the production of small wind turbine. And this is going to guide to deploy and install small wind turbines, and we could follow the performances, also follow the maintenance, bring some help and reparations, and to, of course, have a continuous improvement, like in technology, like in everything you can do today to improve the design, bring complex solutions, and also bring personalized solution to local population that are living in very specific areas. The expected outcomes of this project will be, of course, improvement of the access to electricity for the local populations that are in developing countries and in rural areas especially. This is going to be easier and cheaper and less polluting to access energy for them, which is a big issue in some kind of area, where this is going to bring more energy security. We are going to diversify energy sources and reducing dependence on finite resources like gas, petrol, and etc. This is going to bring, I hope, some kind of economic growth to those areas, creating jobs, innovations in clear energy technologies, and maybe bring this cultural change in local areas that sometimes do not know a lot. I mean, most of the time do not know a lot about those kind of technologies. So as I said, next step one is to develop, test a strong and suitable design that is going to be tested in Europe, I think, in some kind of similar area condition than in developing countries we are targeting. And next, the step number 2 will be to find collaborations with universities, governmental projects, funds, organizations that would be happy to help in this project, because this is not possible to do it alone. This needs so many different skills, and we need more help that we can have. I thank you all for your attentions. For your attention, sorry. If you want further information, you can just text me. I would be very happy to answer you. I was missing a lot of time this week because I'm in personal changes, so I had to do this presentation very brief and consistent. But as I said, if you want any further information, you can just text me. I would be very happy to answer you and to answer your questions, sorry, right now. Thank you so much.
Thanks a lot, Côme. And just so that you know, this is a running project. So then we had other trainees that took over what he left, and then we little by little we build it up, basically.
Yeah, that's the main idea.
There were a couple of questions in the chat. So Niels is asking, printed blades from carbon reinforced plastics, epoxy.
All right. Printing blades from carbon. All right. This I know that with now the I would say you can access now, if you're a private or an organization, you can access to printers that can print carbons, fiber carbon kind of stuff. This is something I unfortunately do not know much about, but I would be very happy to discuss about it, because this is a very good potential for blades. Actually, this is very light and very strong, and this is the weakness of the plastic PLA or ABS or PETG we are using in daily life with printers, is that this is very weak. This does not support a lot of forces. And epoxy, I don't really know about. I think that there is a lot of industrial printers that can print this kind of material, but of course the price of production will be higher, I think.
And then there is a question from Florin about the power.
Are you getting a power coefficient bigger than Betz limit? Actually, no, we are not. I think the more realistic data that I had when I was in Folkecenter was around 0.52, 51, because there is errors into the data of the experiments due to measurements tools, accuracy of the wind, of measurements and stuff like that. So the best I had with the design I've tested is something around 0.52. So 52%. Nice project. I am manufacturing and testing small wind turbine blades in Spain. All right. If you want, we can talk later. We can talk later on to see.
That's a private one.
Okay.
It's a private message.
Yeah, okay. No, that's fine. Sure, sure. That I would be glad to do it.
And Florian is just saying that it was 0.6 in the slides, the coefficient of performance.
Yeah, because the slides are directly from the experiment, but those data were kind of not wrong, but we had some measurement errors. I'm sorry about that, but yeah, it's not possible to go over over 0.6 is not possible in real life. So I'm well aware about that. Do not worry.
And then, yeah, you can see Sven.
Right, Sven, I am involved in a project in Sweden. This is true content project. We have represented some part of you.
I'm involved in a project at the university in Sweden, which seems to complement your project. We have 3D printed some parts from a huge bigger design of small wind turbines. We are planning to test this, for example, in wind tunnel. It would be interesting to get in touch with potential collaboration partners.
Yeah, actually, this is a very good point because having very good wind tunnel is going to a real wind tunnel is going to bring a very accurate measurement. So I would be very glad to do so with you guys. You printing in module and then glue them together. No, I am not doing so. This is more complex because gluing is not strong enough. So as an example for the blades, they were printed in two parts. Each part, those parts, they are linked together thanks to just a tube of metal and some screws. This is basically screws and metal parts to screw in inside. Very simple, and I am using a technology that I've been learning in Folkecenter, which consists to solder PLA and plastic together, thanks to an outside form of plastic. This is something that with PLA as an example, you're going to put heat on the PLA with rotating some kind of tool, and the PLA is going to melt and it's going to solder like you're soldering metal or something. I think you can ask Folkecenter staff. I think you can ask Anchor. Anchor is the one who he told me that kind of technique to solder two pieces of PLA and plastic together. So to link those two parts, I've been using two technology, just metal and screws that is inside. You could see it on the document that Daniel has, and I've been soldering the PLA parts together.
And then, yeah, if you have considered the Piggot's design, the wooden blade.
Oh, Pigot's design. Just I need to have a look at it. Pigot's design. Oh, you mean the wooden blade we are doing in Folkecenter? Like the same ones?
Yeah, you did two blade, but the ones that are designed as a free blade that probably I'll show you.
Oh, you mean having two blades on my prototype?
Yeah, sorry, I will let you take the. Yeah, fine. Now you can unmute yourself.
Oh, thanks for turning the mic on. A very interesting presentation, and at the Mälardalen University in Sweden, we have based our 3D printing on Hugh Pigot's design, which you might call open source. So he makes his blades from wood, but we have looked at how you can 3D print them also from plastic. We are also now trying a new wooden material called Akoya, where we manufacture them from a 3D model. And this is such a proven way of designing a turbine. So I was just curious if you had looked at 3D printing parts for that. In any case, this might be a complement to your valuable input.
Well, okay, so yeah, thank you so much. This is very interesting, but I haven't really think about that already. So we can exchange by email or messages if you want. That would be my pleasure to know more about what you're trying to explain. And you were speaking about Segoya, is that right? About the wood?
Yes, it's a treated wood. I'm writing Akoya now in the chat.
Akoya.
So it's supposed to be very resistant and also keep its shape, which we think is a key property which we need for blades. So we are about to start testing these blades actually. And I have no test results yet, but they have been successfully manufactured from a 3D model.
All right. Okay, so this is a very good step. Okay.
So if plastic is not strong enough, you know, the Akoya could be a wooden material which is strong.
Yeah, that's the main issue with plastic. If you want something small, this is all right. If you want something bigger, you have so many forces that is going to apply to the plastic. So you cannot do it with only plastic. You have to find something to make it stronger inside. And this is going to complexify a lot the manufacturing. So I think your idea of Akoya is something that has a lot of potential.
I can see in the chat that many people are interested in your topic. So if there is a way for us to maybe get back later, those who are interested, I think we have a lot of interesting comment to talk about.
Yeah,
Thank
I'm writing
so
I am writing you my professional email up. And I think, there we go.
There is a question from Amr as well.
All right, sorry, which one?
Yeah, I'm here.
Yeah, sure.
Yeah.
Go ahead.
So thank you so much for the presentation. It's really very interesting, especially the application of 3D printing in small wind turbines. And I don't have a question, but I have just a comment that actually we did some experiments on small wind turbine, printed small wind turbines at Perugia University in Italy. And actually it depends, like the efficiency of the turbine depends on the direction of printing. So sometimes when we print in the direction of the flow, like every layer has its own airfoil shape, this increases the efficiency. While sometimes when we print in different directions, we get degraded efficiency. So
this is due to the layers. I haven't tested that, but I assumed. So I have printed the layers in the same direction as the wind should be, and this is very interesting because I think in function of your design, the wind is going to react differently on the shape of the blade, and then you're going to need to adapt yourself with the layers. So this is very interesting. I haven't thought about the difference the design could do on that.
Like we have a paper, but now it's under review. I hope it's gonna be available soon, so people can
that would be nice.
And we can discuss about that later.
Sure, I'm going to send my email to everyone here. So it's going to be. I do promise you to answer. I do not promise when, but I'm going to answer. So it's going to be all right for everyone. You're welcome. You're welcome. That's my pleasure.
We can move now to the next speaker, and then if you want, what I can do at the end of the session is that I can block the recording, I can leave the camera on, and then the ones who want to keep on discussing, that's a possibility. So
Just to let you know that I need to go away in like 10 minutes.
Yeah, then
So for me, it's not going to be possible. But thank you so much for the invitation, Daniel. That was very very nice of you. And say hello to the staff of Folkecenter.
I will. Thanks.
I miss them. I miss them. I miss them quite a lot. So and I like them a lot. So say thank you and big hello from France.
I will. Thanks. And
all right.
You're
bye everyone.
always welcome to come back. You're always welcome here.
I know. I'm quite a bit busy for 6 months now, but if I have free times, then be sure I'm going to visit.
Perfect. So thanks a lot.